Okay, so we'll begin the urinary system today. So just follow, first of all, it's understand, where these organs lie, what their function is, because later when you do physiology, unless you understand the relationship between blood vessels and what is called the renal tubule, it will be very difficult to understand the physiology, okay? So here, let's look at the organs of which form the entire urinary system. We often also call it the urinary tract, but in this case, the tract, like the gastrointestinal tract, the tract is only that part which has a lumen, which is, hollow, and the one which either transports or stores urine, okay? So the entire urinary system does not really contain, is not the same as the urinary tract. So when you say the urinary system, you really mean the kidneys and the urinary tract, okay? Otherwise, you just call it the urinary system. So let's look at it. So here we have the kidneys, which are present in the abdomen. So you can see this area of the abdomen where they are present. And from ANP1, you should remember, we kind of divided the abdomen into 9 regions. Somewhat like this. You remember that? This area was called the hypochondrium. This was called the epigastrium, hypochondrium. This part here was called actually this is a little bit more like this. So we have the hypochondrium, epigastrium, hypochondrium, umbilical area, pubic area. This was called the inguinal, and this area was known as the lumbar region, right? So you can see here that the kidneys are present here in the abdomen, and they are the organs which produce the urine. They are solid organs. Then once the urine is produced, it is then transported. So it's transported through a tract, and the tract is made up of the ureter, the urinary bladder, and the urethra. So in this urinary tract, the first thing is the ureter, which is a thin muscular tube, and you can see it's present in the abdomen and the pelvis. In fact, half of it lies in the abdomen, and the other half, it kind of crosses over and gets into the pelvic cavity, which is the pelvis. And this helps to transport urine. Then we have this urinary bladder, which is seen in the pelvic cavity just behind the pubic symphysis. So it's the anterior most of these 3 structures which are found in the pelvis. In the females, you have the uterus. So we have the bladder in front, the uterus in the middle, and the rectum behind. In the males, it's only the bladder and the rectum. And it's good to see this relationship because soon we'll be doing the reproductive system, so you should know that. So this is the urinary bladder, which stores urine and then helps to expel it to the outside. It's extremely muscular. And the urethra is the last structure which is present in an area which is known as the perineum. And this helps to transport the urine to the outside. So when the bladder contracts and expels the urine, it goes into the urethra and this passes out. So here you can see all these organs. And let's take a look here.
On April 8, prepare to face the forces of darkness.
Here's a commander of legions. We can't give up now.
On The Hobbit, The Desolation of Smaug, on Blue 8.
As we've just seen, the process of digestion and absorption releases nutrients into the bloodstream. But excess nutrients, salts, minerals, and water, as well as drugs, can also enter the bloodstream through the digestive system. The cells of the body release toxic waste products, ammonia, which lead to less toxic urea by the liver, into the bloodstream. These excess material, drugs, toxins, and wastes allowed to build up in the bloodstream can threaten an individual by throwing off critical chemical balances. The blood and extracellular fluid that bathes body cells must have a close to neutral pH, precisely regulated concentrations of various salts, appropriate levels of water and dissolved substances, and of course, cellular waste products must not be allowed to reach toxic levels. The burden of maintaining proper chemical balance or homeostasis in the body falls largely on the kidneys. Human kidneys are paired, kidney bean-shaped organs located on either side of the spinal column and extending slightly above the waist. Each is approximately 13 centimeters long, 8 centimeters wide, and 2.5 thick. Blood various waste enters each kidney through a renal artery. It has been the blood exits through the renal vein. Urine, which is a mixture of water, dissolved wastes, and toxins, and some excess nutrients filtered out of the blood, leaves each kidney through a narrow muscular tube called the ureter. Peristaltic contraction drive urine through the ureter to the bladder, a hollow muscular chamber that collects and stores urine. Also, the bladder contains smooth muscle capable of controlled expansion. Urine is retained in the bladder by two muscles located just above with the ureter. When the bladder becomes distended, receptors in the walls trigger contractions. The sphincter nearest the bladder, the internal sphincter, is open during these contractions. However, the lower or external voluntary of the reflex pressed by the brain unless bladder distension becomes acute. The average adult bladder will hold about 500 milliliters or approximately a pint of urine. Urinate is triggered by considerably smaller accumulations. Urine completes its journey to the outside through a single narrow tube called the kidney contains a solid outer layer where urine is formed and a hollow inner chamber called the renal pelvis, which is a branched collecting chamber that funnels urine into the ureter. The outer layer of the kidney is divided into a fan-shaped inner renal medulla and an overlying renal cortex. Microscopic examination of these structures reveals an array of tiny individual filters or nephrons. Over 1 million are packed into the cortex of each, with many into the renal medulla. Blood is conducted to each nephron by an arteriole that branches from the renal artery. Within a cup-shaped portion of the nephron, the Bowman's capsule, the arteriole branches of approximately 50 microscopic capillaries that form an intertwined mass, the arteriole leaving the glomerulus is smaller in diameter than the one coming in. Within the forces water and many dissolved substances such as urea, glucose, salts, amino acids, and enzymes capillary wall in a process called filtration. The resulting fluid, called filtrate, is collected in the Bowman's capsule for transport through the tubule.
So that's kind of a very quick review of what are kidney, okay, and how urine is finally formed. So now we'll kind of break it down into little steps and go through all of that. So first, let's answer a few questions. An injury to which of the following regions do you think is going to involve the kidney? It is the lumbar region. Remember, just above the waist, as he said, so it is present here in the lumbar region. The hypogastric is the region just behind the pubic symphysis, which is way down. So if I drew these again for you, and here's the pubic symphysis here, and you talked of the regions. This is the hypogastric, and this is the area where the bladder is. Your kidneys lie pretty much here in the lumbar area, okay? And umbilical area is this part here. The main part of the kidneys is lying in the lumbar region. Now let's look at the functions of the kidney as you saw in the video, and he described it. One is to maintain homeostasis. You want to excrete waste products because, you know, your cells are metabolizing, you digest substances, and there may be toxins which enter inside. You need to take care of it. The body itself produces, like he mentioned, ammonia, which is then converted into urea, which you no longer need. So all of that has to be removed. You need to maintain the pH of your blood at a constant level between 7.35 and 7.45. So if your pH kind of goes up or your pH goes down, you will see later when we do what is called acid-base balance, you will see how the kidney helps in that case. We already did the respiratory system. Remember when in respiratory, if your pH went up, like it got more alkaline, remember you kind of stopped, your breathing became a little slow, shallow, so that you retained carbon dioxide. And if you had, your pH became very acidic, you kind of hyperventilated, so you got rid of the carbon dioxide. So later when we do acid-base balance, we'll be looking at this again. Then it regulates the volume and composition of blood, and again in composition is the pH. And in the volumes, you can understand that if, for example, your blood volume is very low, then you automatically pass less urine out. And we did the endocrine system, you know that ADH is produced when your blood volume becomes very low. So you want to conserve water. And why do you want to conserve water? After all, in the end, the water goes into the plasma, right? So again, that's how the kidney also helps, because ADH and aldosterone act on the kidney. So you can see that it helps to maintain the volume and the composition. So it's both pH and how much urine is going to be passed out of the body based on whether the volume is normal or not. The kidneys also actually produce glucose, and a great quantity of glucose can be shunted into the bloodstream when somebody is starved. The kidney could be one of those organs which releases glucose into the bloodstream. So it's one of those places which produces glucose. It also produces a number of hormones and other substances. Erythropoietin is something you've already seen. You remember erythropoietin, which we did when we were doing blood for erythropoiesis. The kidney, in fact, in the kidney, and he talked of those arterioles, and we'll see that later, there is an arteriole called the afferent arteriole that produces a hormone called renin. So the afferent arteriole produces renin. And do any of you remember where renin was, where we talked about renin earlier? 2 systems ago. Not the system we just did digestive, but a system ago in the endocrine. Do you remember? Where was it? I'll give you a hint. Something to do with aldosterone. Doesn't ring a bell? So remember we had something known as the renin-angiotensin system. Okay? There was something called the renin-angiotensin system which was actually the major factor which caused release of aldosterone from the adrenal cortex. So this renin is actually something which is produced in the kidney, and now we'll actually tie it in and see how aldosterone is later going to be released. So renin is one of the substances. Erythropoietin we already did. And vitamin D, it is activated under the skin through ultraviolet light, and then it goes to the kidney and it's further activated, and this helps in the absorption of calcium. So you can see how, the kidney has a variety of functions. So let's look at this. One of the functions of the kidney is to produce erythropoietin. So what would be the effect in a person with kidney damage? So here's where you have to really recall all that you did earlier. Anemia, yes, very good. Not bleeding disorders. Erythropoiesis is production of red blood cells. So if the erythropoietin is not produced, red blood cells will not be produced properly, so the person will have anemia. In fact, anybody who's on dialysis, when a person's on dialysis, obviously it means the kidney is not functioning. They usually are anemic and they have to be given synthetic erythropoietin. Let's look at the external appearance of the kidney. So it's kind of a bean-shaped organ. And you can see it has a convex lateral surface. Notice this lateral surface is convex. The medial surface is concave. The medial surface is concave. And this medial surface has this area where structures enter and leave, and that is known as the hilum. Remember when we did the lungs too, on the medial surface, you had an area where structures were entering and leaving. Even in the lymph node, we had that. So wherever structures enter and leave, you have hilum. The other word for hilum actually is gateway. That's what a hilum means. So this medial surface has this indentation here, which is called the hilum, and you can see the lateral surface is the one which is convex. If you also look into the kidney, if I kind of removed all these structures from here, if I removed all these structures and kind of looked at the medial surface of the kidney, it is actually kind of indented. So, it's a little, if I'm looking at it from the side, this is how it is. It's indented. So this indentation here, if you look, this is what it's showing you. That space on the medial side is known as the renal sinus. It's kind of a space. It's not solid. It's kind of as someone scooped it out a little bit. So this space is called the renal sinus, and into this renal sinus is where all these structures of or the hilum opens. Okay? So that's what the renal sinus is. It's usually filled with fat, and the hilum opens into the renal sinus. And three main structures are present at the hilum. And this was true even if you remember, in the respiratory system, when we did the lung, you had a vein, an artery, the pulmonary vein, pulmonary artery, and you had a bronchus, right? A third structure. So here, because it's the kidney, you have the renal vein, the renal artery, and we have the ureter, and this is a part of the ureter known as the pelvis of the ureter. Pelvis is a dilated part of the ureter. It's often also called renal pelvis, though that term is not correct because the pelvis really is part of the ureter and not of the kidney. So that's why I have it as pelvis of the ureter. So these are the three main structures at the hilum. You also have nerves and lymphatics as always. Now the kidney has three coverings. So you have an inner covering, and then you'll have a second layer and a third layer. So the inner covering is called the fibrous capsule. The middle layer is a layer of fat, and since it goes around the kidney, it's called perirenal, peri meaning going around like perimeter. And the outer is again just condensation of fascia called renal fascia. So let's look here at the three layers which we can see, the coverings of the kidney. So this one here, this beige colored one, this is the innermost layer. So this beige one is the innermost layer, and it's the fibrous layer, and usually you can strip it off quite easily, as you can see here. It's been just stripped off. If you've ever bought kidneys at the grocery market, you can actually really just strip off this fibrous capsule. In someone with a diseased kidney, it gets stuck and it's not so easy to remove it. The second layer is a covering of peritoneal fat, which goes all around the kidney like this. So this is known as perirenal fat. And then on the outside, the outermost covering, so this one is the outermost covering, is condensation of connective tissue present in the abdomen, and that forms what is known as renal fascia. Renal to do with the kidney, and fascia is just connective tissue. So this green layer on the outside is the renal fascia. So this is when you're looking at the kidney in a longitudinal section. So imagine if you took a section through the abdomen at this part, you can see the kidneys lying on the posterior part of the abdomen. This layer which surrounds the kidney here, covering it, this is the fibrous capsule. Outer to that is this perirenal fat. And then the outermost layer, which you can see, this outermost layer, this would be the renal fascia. Okay, so three coverings, and you have three coverings, they kind of help it. Now, think of why you would need this fat layer. So what do you think is the primary function of that perirenal fat? Very good. Yes, it's for protection and anchorage. All organs usually have a lot of fat there to keep them in place and to protect them, right? So what do you think would happen if the perirenal fat were depleted? Yes, the correct answer is the kidney would drop from its normal position. Remember, it anchors it and it protects it. It's not that the kidney would atrophy. Only the fat has gone. The kidney is otherwise normal. So nothing is keeping in place. So imagine it's like this. You've got something on the wall and you've kind of padded something all around, and you remove that padding. What will happen? Whatever's on the wall will kind of drop down, right? This process where the kidney drops from its position to somewhere it comes from its lumbar position and may come into the inguinal region. This dropping down of the kidney is known as ptosis. And it was seen in the concentration camps where, people were starved and they did not have food to eat. So the body kind of used up all the fat wherever it was to provide energy. So the kidneys would drop down, but the ureters remained in their normal position. So you can imagine if this is the normal position of the kidney and it kind of drops down here like this, but the ureter gets kinked. So when it gets kinked, urine can't pass out normally. So what happened? It kind of backs up, and usually these people end up with kidney problems. So that's one of the things that happens with this. Okay, so that process where it drops from its normal position is known as ptosis. So actually, we are out of time, so let's stop here.